Hello, guys. We're getting close to the end of the chapter. But in this section, we are talking about the nature of roots. And just in the previous section, remember, I did say if we're talking about roots, just think about what? Think about x intercepts, right? And remember, x intercepts are the values of x where y is equals to 0, right? And these values, where do we find them? We find them on our x-axis, right? They lie directly on our x-axis. That is why they call x-intercepts. So the nature of roots, or the nature of our intercepts, we use this thing called the discriminant, um, to talk about the nature of the roots, you know. And the discriminant, this is the symbol that is used, right? You will see it through all the course, and in grade 12 as well it will appear. The discriminant is b squared minus 4ac. So if you try to remember very well, under the quadratic formula we dealt with this and we saw something similar to this. Remember, quadratic formula is what? Quadratic formula says x is equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. Yeah, divided by 2a. So you realize that the whatever is inside the square root is our discriminant, right? That is our discriminant, and it tells us the nature of the roots. How? It's gonna tell us the nature of the roots, whether our roots are imaginary or whether they are real numbers, and so forth and so forth. So there's a nice diagram that sort of break it down nice and easy, for us to remember it. So remember, this symbol is for the discriminant, which is what? B squared minus 4ac. So our discriminant is not square root of this, it's just that b squared minus 4ac. That is the discriminant, right? So now let's say you're doing your maths, then you find out that your discriminant is what? Is negative, right? If your discriminant is negative, you have non-real roots or imaginary roots, right? You have non-real roots or imaginary roots. Just to make an example, we had an equation. I think it was 3x minus 3x squared, and then here it was plus 5x, here it was minus 8, right? So here you realize that b squared minus 4ac is what? It's gonna be 25 from 5 squared. Let me go step by step. 5 squared minus 4 into minus 3 minus 8, right? This is 25 minus 96, right? Let's see it. 4 times 3 times what? 8. 96. Yeah. So now 25 minus 96, it's minus 71. So this is negative. That means what? That means you have square root of negative 71, which we know we don't have a square root of a negative number, making the whole thing imaginary roots or non-real roots. It simply says that we do not have our roots. If I were to plot this thing, say this is my equation, assuming that my a is positive, I'm gonna have something like this. You realize that here I don't have any roots, or maybe something like this. I do not have any roots. This parabola doesn't cross our x intercept, or it doesn't cross our x-axis. That means in this case we do not have the roots, right? Let me erase this. Now we talk about, now if our discriminant is positive, it means or let me just say, if our discriminant is 0 or greater than 0, these are the things that happen. So you could either have equal roots. Equal roots happens if your discriminant is 0, and so let's just talk about that. Equal roots, that's when you will have something like, a good example would be x squared minus, should it be minus? Yes, make it minus let's say 4x plus 4, right? When you factorize this thing, say equals to 0, when you factorize this thing, what are you gonna get? You find, say, two numbers. Let me just open my brackets. Two numbers, you multiply them, you get 4, you add or subtract them, you get minus 4. It's what? It's minus 2 minus 2. And you can just further factorize this whole thing, you realize that you have minus 2 squared, right? So here you realize that your only value of x is what? Is x is equals to 2, right? That's the only root that we have, or you can say we have multiple roots of x is equals to 2, so how does this happen? Let us calculate our discriminant b squared minus 4ac. So our discriminant b squared, it's 4 squared minus 4 into 1. This is a, and our c is what? Is 4, right? So you have 16 minus 16 equals to 0. So your discriminant here, our discriminant is equals to 0, and that is why we are having this minus 2. Since our graph is positive, you're gonna have something like this if you plot it on our graph. So it's gonna be something like this on the positive side, and then right here it's where x is equals to 2, right? That's what your graph is gonna look like, and that's where you have equal roots, right? So now if your discriminant is not equals to 0, like in this example, your discriminant is positive but is not equals to 0, it's some number that is equals to 0, so you can have either rational roots or you can either have rational roots or you can have irrational roots, right? So yeah, by rational roots you will have, say, maybe x is equals to, this is rational roots, 2, or x is equals to 3, right? And that's like you having rational roots, that's you having rational roots. But if you have irrational roots, it will be something like you have x is equals to square root of 2 or x is equals to square root of 3. Then you have what? You have irrational roots, right? Basically that's it. This that's just it. Let us see what problems we can do, to emphasize this. Just try to always remember this diagram or just know it by heart. Yeah, cool stuff. So these are the problems we're gonna do. Number one, the first one, we have to find the root for the first one, the nature of the root, right? So remember I said what determines the nature of the roots is your discriminant defined by b squared minus 4ac. And now I'm just gonna substitute. My b is gonna be minus 6 squared minus 4 into my a, my c minus 1, right? It's 36, and 4 times 6, that's 24. Negative plus, so 24. So what do you have? You add this to, it's 50. I think it's 60. Yeah, I think the answer is 60. I'll just check. 36 plus 24. Bang! Cool stuff. So I already know that I have real roots. That's the first thing I can say. My roots are real roots. And since this thing is equals to 60, my discriminant is equals to 0. So I don't have equal roots. I don't have equal roots. So now I can just check if are they rational or irrational, right? And for me to check that out, I'm just gonna find the square root of 60, and yeah, I think the square root of 60, it's some irrational number, 7.745, blah, 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 blah. Yeah, so you already see here you're gonna have a rational number if you find the root of that equation. The roots won't be this, but whatever the roots are gonna be, they're gonna be irrational roots, right? Yeah, let's do the second one. This one is quite interesting in a sense that we don't have z, you know, we only have z squared, and that's just it. Z squared minus 3. So let's find the nature of the roots in this case. Let me use purple. A discriminant defined by b squared minus 4ac. So what do I have? B squared. What is my b? B is 0. Bam. Right, so my b is 0 this side. I do not have a b, perhaps maybe to make it a bit more clearer, let me, oh no, what am I doing, bro? Yeah, cool stuff. And I want to erase this thing. I don't know why I did it. Yeah, so let's say here I can say I have z squared plus 0 z minus 3. Very interesting, right? Yeah, so in this case I can just see clearly that my b is 0. So 0 minus 4, a which is 1, c which is minus 3, and here I have what? I have 12. So the same thing goes, I have real roots, right? And I put square root. I'm sure I'm gonna get some irrational number, probably. Let me just guess. I think here the answer is gonna be something like 2. Yes, it have to be 2 root 3, because in 12 I have square root of 4 times 3, which is square root of 4 multiplied by square root of 3, which is 2 root 3. And root 3 is an irrational number, so it doesn't even matter whether you put a 2 behind, it's still gonna be a rational number. So in this case you have irrational roots, right? So there's a bit challenging, not really challenging, but it's a bit spicy example under the nature of the roots. So yeah, let's do it. Let's get into it. Yeah, so in this equation they say, given that whatever that whole equation says, it's a very long one. And you know that k is not equals to minus 1. They wanted to show that your discriminant is shown by this. Discriminant is equals to k squared plus 6bk plus b squared plus 8. So yeah, let me go for it. So let's do it. My first instinct says that I might have to break the bracket and see what I will get off it. So I still have x squared plus bx minus 2, and then I have plus kx squared plus, I'm now multiplying k into the brackets, 3kx plus 2k, the whole thing being equals to 0. Now I can just group the like terms. So I have x squared, right? So that will be x squared plus kx squared. Now I have x and I have x, right? So that will be plus bx plus 3kx. Yeah, I want to maybe say some apologies. Apparently the neighbors are fighting. Hopefully their voices will be inaudible. Hopefully their voices will be inaudible. So now it's my constants. I have this guy over here and this one. So for my constants, I have plus 2k minus 2 equals to 0, right? So this is my x-axis, no, my x squared, my x, and I used the wrong color there. This is my x, and right here this is my constants. So now I'm just gonna do what, let me take out x, so I'm gonna have open bracket 1 plus k, then I have x squared, plus I'm gonna have open bracket b plus 3k, and then I have x, then plus this one. I may not need to, yeah, I don't think I will need to take the 2 out, and maybe let me do it, so it'll be 2 minus 1. Yeah, so now with what I have done here, I know this is a, I know this is what, this is b, and I know this is c, right? So the formula, it says, let me use purple, discriminant is b squared minus 4ac, right? So now I'm gonna go and say I have b minus, no, b plus 3k, so I'm squaring b squared, then I am minusing 4 into a, which is 1 plus k, and multiplying it into c. I think here I may just use the original one before, let me just do it that way right here. 2k minus 2 minus 2. Yeah, so I have this. Now it's just a matter of me multiplying the whole thing. If I square this, it's gonna be b squared, b multiplied by 3k, that's 3bk, multiplied by 2, that's 6bk, and I square that, I have 9 k squared, and I'm gonna have minus 4 into, right here I have this is gonna be 2k minus 2 plus 2k squared minus 2k, right? Yeah, so then it's b squared plus 6bk, I forgot the sign here, plus 9k squared minus 8k plus 8 plus 8 minus 8k again, 8k squared. What's happening here? What's happening here? And then this is gonna be the last one, plus 8k. Yeah, let me see. So now it's just a matter of me grouping the like terms again. I only have 1b squared, and I have 6bk, and then as for the k squared, let's look at this. These are gonna cancel out each other. It's like 8 minus 8, or 8k minus 8k, and right here I'm gonna have 1, so I can just say plus k squared plus 8. So the 8 came from here. This, let me use a purple. This came from this 2. Yeah, let me see. It's damn. Wait, what? It's damn. I have k squared and they have b squared. What did I do wrong? What is it that I did wrong? let me see. But no, oh yes, yeah, no, everything is fine. Everything is fine. They started with yeah, I started there with k squared and here it's b squared. Yeah, absolutely fine. The answer is correct. Let's go to the next one. All right, cool. So they say if b equals to 0, discuss the nature of the roots of the equation. All right, so now let's remember what we have. Our discriminant is what? Our discriminant is k squared 6bk plus b squared plus 8. So they say b equals to 0. Now this is us substituting. Yeah? So we have k squared, b equals to 0, so plus 6 into 0 k plus 0 squared plus 8. You end up with k squared. This is 0 plus 8, right? So it doesn't really matter what k is gonna be because k is squared. The number that's gonna come out here is positive, and you add a positive number with a positive number from 8. Our 8 is positive, so you know from this case you have what? You have real roots, right? You have real roots, and now it's just going to depend on k as for whether the roots of this equation are going to be irrational or rational. So in the next yeah, it is going to depend on that, right? So look at the last example here, number C. It says, it's very interesting. In fact, it says if b equals to 2, find the value or the values of k for which the roots are equal. Remember, if the roots are equal, your discriminant is 0, right? So we take our discriminant, which is k squared plus 6bk plus b squared plus 8, and what we have to have equal roots, right? So here when we substitute our 2, we have the discriminant being equals to what? K squared plus 6b which is 2, and then 2 squared plus 8. The whole thing has to be 0. So now we go on. K, you have 12k. You have 4 plus 8. That's going to be what? It's going to be 12, right? So we're now solving for k. Since my coefficient of k squared is 1, I can just open my brackets. K, yeah, yep, yeah, let's think now. Let's think. Find the nature of the okay, b is 2. We have already substituted. Find the value of the values of k for which we will have equal roots. For us to have equal roots, our discriminant has to be 0. So now we equated our discriminant to be 0 right here. So now we're trying to solve for the value of k where our discriminant is going to be 0, given that b is equals to 2. Now I'm trying to think. I have 12 multiplied by 1, 12 and 1 multiplied by 12, that's 12. This one is going to be a very interesting problem. You will see why. So factors of 12 is 1 and 12, 2 and 6, 3 and 4, and that's it. So we have factors. These factors of 12, they give us 12 if we multiply each pair. But the problem is there is no pair that if we add them gives us, if we add them it gives us 12. For example, here we get 13, we get 8, we get 7, right? So we realize here our method doesn't really work. So let's try a different method. Since we have already done we have already solved for this thing. What is this thing called? What is this thing called? We have already solved like using the quadratic equation. So let's use it and say k equals to minus 12 minus 12 plus or minus square root of what? Square root of 12 squared. Now b squared, it's gonna be minus 4 into a, which is 1, and c, which is 12, and then 2 multiplied by 1, right? So I have minus 12 plus or minus, I have 144 minus 48 divided by 2, so that's minus 12 plus or minus, let us see, square root of 144 minus 48. So the answer, the simplified answer straight from the calculator, 4 root 6 divided by 2. I can take out 2 as a common factor and say what? Say I have 2, then I'll have 6 minus 6 here, plus or minus 2 root 6, and then I still have my 2. These 2, they cancel out, and now k is equals to what? Minus 6 plus 2 root 6, or k equals to minus 6 minus 2 root 6. Yeah, bam, we are done. So few things to highlight. Remember how when you're trying to solve for x and you try to factorize, but you cannot factorize in the way that you are used to, like in this example, we tried both our methods and it couldn't work. But remember, we are trying to solve for k. We can just use the quadratic formula, substitute the values, and then we get the values of k. So it's only at if k is equals to these values right here where we will have equal roots, given that b equals to 2. And that is the end of this section. I'm just gonna now charge the tablet, of which after we will do quadratic inequalities, right? Quadratic inequalities, just for spoilers, it's where you have you have your quadratic equation this side, and here it can be either equals to, no, less than, greater than or equals to, smaller than or equals to. That's where we deal with this, and then here you will just have whatever whatever. Yeah, you have your quadratic equation, and then you have your signs, and yeah, that's what we'll be doing in the next section. See you then.